Now, our numbers are these: 0.30 inches. And now, does the area really matter? Well, no, we can just look at inches applied by the system here. It doesn't matter how long the wheel line is. We know that we're going to water in any given square foot 11.5 hours every 10 days. So we're really looking at any one given square foot in a situation like this, not a full field. To find our total value for the operation, let's see where this takes us. So we're going to put on this much water times 10 days. That will give us a total amount of water that we have to apply. So we need to apply 3 inches over 10 days. Now, how fast do we have to put the water into the ground? Well, we know we're going to put down 3 inches. We got 11.5 hours to do it. And we get ourselves a precipitation rate. Well, in this case, an application rate for our system. So we have 3 divided by 11.5, and that means we have to put water on at the rate of 0.26 inches per hour. And so we design our wheel line nozzles to flow at a rate of 0.26 of an inch per hour. Now we have to check for one more thing in this process. What is it? What's the other major concern we have besides our application rate? With water getting into the soil. The intake rate, sure. We have to make sure that the soil can intake the water at this rate. You know, if we have a heavy clay soil, this may not cut the mustard. But if it's a silt loam up through the sands, your intake rates will probably be fine at 0.26 of an inch per hour. But you must check your soil characteristic intake rate to make sure that your system can produce the amount of water and make sure the soil can handle that amount of water. Now, from here, we can calculate the total gallons per minute by knowing how many sprinklers we're running on the line.
If the ground couldn't take that much water a minute, what would you have to change, like your water window? You'd have to water longer?
Okay, the question is, if the ground won't take the water that fast, what could we change? And one thing we could do is lengthen the time of set, isn't it? So we put less water on per hour. That would be one solution. The other thing is to reduce shorten the frequency. Maybe you have to cut this back to 9 days or 8 days or 7 days and put more lines in the field. Because we're just watering one piece of the field here. We're just watering 20 valves. There might be 60 valves out in this field. You know, if you had a fair-sized field out there, you could have 3 or 4 wheel lines out there. So yeah, you can reduce the number of days in the rotation or increase the number of hours in the set. Now notice that this turned out to be a half a day. The standard set changes for hand line or wheel line are 8 hours, 12 hours, and 24 hours. Because you have to be consistent on a daily basis. It's hard to go out at 3 o'clock in the morning to move the line. You can't see what you're doing. So you got to do it in daylight hours so that it works. And so what you do is you pick time frames that fit. And in the summertime, you can do 8-hour changes and it'll work. Some guys will even go to 6-hour changes if they're trying to pre-emerge new seeding. But you're going to be out there, it's going to be pretty dark on one of those set changes. But it could be done in the summertime. So there's considerations on all of these systems as to how you go about doing it. So, but this would give you the concept of how we do this. Now when we get into the irrigation design class, we go into great detail on every kind of system on how to go about doing this process. And basically we work off the solid set system, which is turf or ag, solid set, they work the same, and we just expand it for these other types of systems, where we end up with expanding the frequency when we get into hand line and wheel line. So we have a solid set, we can go out there and effectively run every circuit every day on a solid set. It doesn't matter what kind of system it is. It could be an orchard, it could be turf, it could be a pasture, whatever it might be. There's the capability of daily watering, or multiple times per day watering, and especially if it's automated. Piece of cake, just program the controller and walk away from it. If you need it to water 3 cycles a day, it'll water 3 cycles a day. Cannot do that with a hand line. You'd be out there walking your feet off, moving pipe. I mean, you're trying to minimize labor with this system. That means you're going to try to stretch the amount of times between irrigations to reduce your labor of moving pipe. That's why you don't see hand lines on potatoes very often. You just have to move them too often, too fast and too quick. They'll go out and solid set potatoes instead of putting out hand lines on them. Put aluminum hand line, but they'll solid set it, because otherwise you have to move across it about every 3 days. And boy, you're really packing a lot of pipe. And you'll be making those moves every 6 hours probably. With alfalfa, we might go 12-hour, pretty common to go 12-hour sets and go on a 10 or 12 or even 14-day rotation. If our soil can take that kind of water. You know, we got a real deep root zone. See, here we're starting to look at crops and how different crops are affected. You got a 5-foot root zone, you got a lot of water holding capacity and a good silt soil. You can go 14 days on alfalfa between irrigations with a hand line or a wheel line in this valley and still get back and never put that crop into stress. Just because of the huge reservoir of water you have in the soil. Now you can't do that on turf because you're working off of a 6-inch profile instead of a 5-foot profile. Now all of a sudden you got about 2 days in this valley. That 6 inches, you're going to lose its effective value in 2 days in this valley. So if you schedule more than 2 days between irrigations in July and mid-August, in this country, in this particular valley, you're going to have stress on turf. So that's how you can use the knowledge that you're picking up now to start making a lot of these different decisions that have to be made on a daily basis out in the real world.